This is Radio TV Phononut, and here's an Emerson battery-operated portable radio from about 1938-39. Just standard broadcast AM only. Cabinet's in fair shape, about what I would expect for a radio of this type. Alright, I've got the back cover taken off, and here's the chassis. It uses a 5-tube chassis, converter and converter tube, first IF amplifier, second IF amplifier, detector and first audio, and then an audio output tube. And this requires two 45-volt batteries wired in parallel, or series for the 90-volt supply, and a 1.5-volt battery for the filament voltage. And surprisingly enough, these battery cables look to be in pretty good shape. They're cloth covered, which is nice. And the loop antenna is made into the top of the case here, with external antenna and ground connections here on the back. The screws that hold the back cover on, is what you use to affix those connections in place if one is needed. Now when we fix this, I'll rig it up with about 10 9-volt batteries wired in series, and then a couple of D cells in parallel for the filament voltage, and that should be sufficient. Alright, let's get it down to the workbench and see if we can get this thing going. Alright, I have the ohm meter connected across the filament battery connection. Now let's click it on and see if we get continuity across it. And we do get continuity. That's a good sign. That means that the power switch is good and the tube filaments are not burned out, or at least not all of them anyway. I get nervous when I flip one of these on and get no continuity, because many times that's because all of the tube filaments are burned out because it's been wired wrong. Alright, we have the radio connected to the power supply. Let's click it on and see what happens. It sounds like absolutely nothing is happening. I'm touching the grid of the audio amplifier tube and not getting anything. Alright, one reason why it's not working is because we have a busted tube here. Looks like an IF amplifier tube, but I think this would be a good time to remove the chassis and troubleshoot it. Well, it looks like we have 3 matching chassis mounting bolts, so that tells us that this has never been removed from the cabinet, or if somebody removed it, they were careful to put all the correct mounting bolts back. Alright, here's the underside of the chassis. It looks pretty good. I don't see any immediate evidence of any tampering. Alright, here's the tube. It's a 1N5, which is one of the IF amplifier tubes, and as you can see, it's one of the tall ones. And those are getting kind of hard to find. The short ones are easy to find, but not the tall ones. Well, before we go round up a tube, I'm going to power this up again, and with this tube that's possibly shorted out of the way, I'll see if our audio circuit passes a signal. Right, looking at the plate of the audio output tube, I've got 58 volts. That seems a bit low. Looking at the screen grid, we have 70. Looking at the other side of this 100k ohm resistor that feeds plate voltage to the first audio tube, we have 9.5 volts. That definitely seems a little low. Alright, looking at the control grid of the audio output tube, we have 1.6 volts, so we know that coupling capacitor is likely leaky. And we have this resistor. It's all corroded on the ends. It looks like the bias resistor for the control grid, probably a 500k, and it's all corroded up. Let's check it and see what it measures. Alright, back to the plate. We have 58 volts. I'm going to cut this plate bypass capacitor loose and see if it jumps up. Alright, no, it didn't jump up any. Since that voltage is low, I suspect this tube is being turned full on and overconducting more than it should. So yeah, we need to replace this leaky coupling capacitor and check this resistor here. It's going to get replaced no matter how it checks, because anything that corroded, you know it don't have long for this world, even if it is still good. Alright, coupling cap is pulled loose, and this resistor is reading 780K, which is probably a bit high. I suspect this is a 500K. I'll have to go procure the schematic, but with this coupling cap loose, let's fire it back up and see what kind of B+ voltage we get on the plate. And it jumped up to 76 volts, which is what I was wanting to see, something in that neighborhood. So yeah, this coupling capacitor was leaky and throwing positive DC onto the grid of the output tube and causing it to turn on full force and overconduct, and that of course places a load on the power supply and drags the B+ down. It's 79 on the screen grid. And when I touch the control grid of the output tube, I now get a buzz in the speaker. And where we had 9 volts on the plate of the first audio tube, we now have 53 volts. So yeah, this leaky coupling capacitor was loading down the whole thing. Alright, body in dot. I now see the color code once I got it out and turned it up. So yellow, first digit would be 4, black, second digit would be 0, and the dot is also yellow. That would be 10,000, so that would translate into 400K. So we can put a 390K in there and it should be good to go, but I will go consult the schematic and make sure, because I know sometimes the paint they use can sometimes fade and make it look like it's another color that it's not supposed to be, so I will consult the schematic. So yeah, where these resistors corroded and it's not going to cooperate, but it just broke off. Well heck, forget it. But yeah, where these leads are so corroded, it just broke off right where it enters the resistor, and every one of those resistors are that way, so they're going to have to be replaced. Now this resistor here looks like a newer style resistor, and I suspect it's a replacement, seeing as how it's not like any of the other resistors in here. Okay, I replaced the coupling cap between the first audio and the output tube, as well as the plate bypass cap and this grid bias resistor, and we now have on the plate 77 volts. That's good. Screen 80. That's good. Let me touch the grid cap and see if we get anything volume wide open. And yes, our audio stage is now alive. Now what I want to do is round up a 1N5 tube and plug in and just see if we get any kind of reception. But yeah, this one severely leaky coupling cap was turning the output tube full on, and that was loading down everything. Alright, here's the old capacitor. Yeah, it's basically shorted. Now when I check it with an ohm meter, I can go all the way up to the 2 meg range and not get any resistance, but when voltage is applied to this capacitor, it acts like it's basically acting like a short circuit. And here's the plate bypass capacitor, and it's no better. Light just stays on all the time, so yeah. Both of those are basically shorted. Alright, power supply is connected via clip leads. The cabinet antenna is connected via clip leads. Yeah, this is pretty much looking like an ICU patient on life support. Well, it kind of is, only this is a radio and not a human. I think this is a 1N5 tube that I located. So so let's flip it on and see what happens. That sounds interesting. Let's see if we get any stations. No stations, just a bunch of oscillation. Alright, there's one thing I want to check, and that's that electrolytic bypass capacitor. If it opens up, it can cause that. Yep, that's the problem. Alright, let's get that one replaced.
That would play.
Alright, there we go.
You know, in his situation, if it doesn't go well, then you have another stick to come back for.
So now that tells us that all the major organs are good. So what we had to do just to get this thing to play was replace the broken 1N5 IF amplifier tube, replace the plate to grid coupling capacitor from the first audio to the output tube, and replace the electrolytic bypass capacitor that's on the B+ line. That's what ultimately was needed to get the set playing. Now, we replaced that plate bypass capacitor while we were on this side, but I don't think that was keeping the set from playing. And I replaced that corroded up grid bias resistor that was up in value. That wouldn't have kept the set from playing. I just went ahead and replaced it because it was corroded and the leads broke off of it. And we're going to have to do the same thing to these other corroded resistors in here.
Before we let you go,
but we're now to a point where we know all of the major organs are good, or the set wouldn't be playing. So I think we can just go ahead and recap this and change out all these corroded resistors, and we ought to be pretty close to being good to go at that point. Alright, I'm checking my progress as I go, just in case there's a problem. I won't have to chase myself all over the chassis trying to figure it out. Alright, this resistor here, which is a screen resistor on the converter tube, here is the original here. There's not a lot you can tell about that. It measures about 86,000 ohms. And the schematic value was kind of smudgy on what I printed out, so I went and looked at it directly on the computer screen, and it's 30K. So apparently this used to be orange. It has faded to some other color now, but anyway, it's replaced now with a 33K. And we'll just continue this. Okay, we have all the capacitors replaced and all of those nasty corroded resistors replaced as well. The only capacitor that was a bit out of the ordinary was this .0002, that's right, 200 picofarad paper capacitor that couples the first and second IF stages together. And I replaced that with a 220 picofarad ceramic disc. And we'll now test this on the leakage tester. It's a solar seal type, and I'm pretty sure we know what the results are going to be before we even check, but we'll check it anyway. Alright, watch the neon light. Yep, it's leaky. Not as bad as some of the others we've tested, but still leaky and needs to be replaced. Okay, here's the capacitor on the schematic. As you can see, it's coupled basically the same way as the final audio stage, from the plate of the first IF amplifier tube to the grid of the second IF amplifier tube, and if that capacitor becomes leaky, it will place a positive DC voltage on that grid of the second amplifier tube and cause it to conduct full on, and that can cause all sorts of unwanted problems. Alright, now let's fire this up and see if it still plays. And no, it's not still playing, so what in the devil happened? Alright, it looks like our local oscillator is either not running or is very weak. We're getting negative 0.04, 0.6, 0.8. It keeps bouncing around. Alright, get the signal generator up here and see if I can blow a 455 kilocycle signal through this. Alright, I'm injecting a signal at the final IF stage. Nothing. Moving back to the first IF tube. Nothing, which it stands to reason if there's nothing at the final stage, there's not going to be anything anywhere else. Nothing. So something happened. Alright, I think the trouble is in our final IF stage based on not being able to blow a signal directly through it, and our plate voltage is excessively high, like maybe the tube's not conducting. But I've done about all I want to do to this tonight, so I think tomorrow, just for fun, we're going to break out the signal tracer and play around with it, since we haven't played around with that in a very long time. Alright, here's our signal tracer, an ICO model 147 from, I believe, about 1957. This is the first time you've ever seen this piece, because I haven't had it very long. The previous model was an older ICO 145, but I decided I wanted one with the tuning eye tube and one with a noise test function. And just to show you how little I know, figured I could just hop on eBay and get one that needed overhauling for 15 or 20 bucks. Well, wrong. All the ones I was seeing, like this, and the similar Heathkit models were going for $150, $200, sometimes $250, $300 or more, which is totally nuts. And I said to myself, I'm not paying that. I'll build one out of a piece of junk radio before I pay that kind of money for one. So I kept watching buy it now listings, and then, as it would always happen, the $50 and $60 stuff that popped up was either a rust bucket or popped up during a time when my finances wouldn't allow, and those listings disappeared within hours of being listed. Well, finally this one popped up for a buy it now price that I could live with. It wasn't as cheap as I would have wanted, but it is what it is. I can remember a time when you could pick these things up at Ham Fest and antique radio meets for $10 or $15, but from what they tell me, the guitar people have figured out ways to use these for amplifiers, and well, there you go. There goes the cheap signal tracers. So basically all this probe is a crystal diode to strip the RF off and leave a weak audio signal coming out of the probe, and that's fed into the input of this signal tracer, which is really nothing more than a very sensitive audio amplifier. Alright, I'll now touch it to the grid cap of the converter tube and see what happens, and we'll have to crank our gain pretty high up because there'll be a very weak signal here. Well, now I'm getting a very weak signal on the radio on 1390. And we're getting it through the signal tracer. Alright, let's move to the grid cap of the first IF amplifier tube, and it should be louder. And it is. Alright, I changed the station to WMOX. 1390 is just too highly modulated. It just gives me, I can't even get an accurate reading here, so at the control, the grid of the converter tube, I get very little. I get more at the grid of the first IF amplifier. Now let's move to the second IF amplifier.
I love the power rankings.
Yeah.
You got them above Harden, career versus career.
Yeah, I do.
Yep. You got them over A.
That's real good.
You got
Allen Iverson was phenomenal.
So we know everything is working up until it goes into the second IF amplifier.
It's ridiculous.
Okay, I've got the gain turned way down on the signal tracer. I'm going to touch the grid cap of the second IF amplifier tube again, and you can hear we have something. Now I'm going to move to the plate of the second IF amplifier tube. That will be where the signal is coming out of the tube. Now this probe has a blocking capacitor in it to prevent DC from getting to that crystal diode in there, because high DC voltage would cream puff it. Alright, now let's touch the probe to the terminal here with the blue wire on it. That would be our plate, and it should be a good bit louder. And as you can tell, it's very much louder. So this stage here is doing exactly what it's supposed to do. So that tells us that our problem, I can touch the grid cap and get a bit of a hum from the speaker. So that tells us our problem is either in the detector stage or the first audio or final output stage, and I'm betting detector or first audio stage. Okay, so we had good strong output on the plate of the second IF amplifier tube. So now I have my signal tracer set for audio. We have a cable plugged into the audio input jack, and we're going to test the input of the volume control and see what's there. Alright, here we are on the input of the volume control, and with the signal generator cranked wide open, I'm just barely getting something. It should be blowing the roof off, and we're barely getting something out of the radio speaker too, so both the signal tracer and the radio speaker are about equal, so it's something here in our detector, our first audio stage, which is what I figured it was anyway once I saw that there was a good signal on the second IF amplifier. Turn that down a bit. Okay, the output of the second IF transformer going into the detector.
It's also a great resource for shooters.
As you can tell, it's plenty hot there, so something in our detector circuit is fouled up. Now, did I make a mistake, or did something take a dump on it? Alright, making some resistance measurements. I'm checking from where the audio enters the volume control to ground, and I'm reading 55 ohms, so that's entirely too low, I do believe. Alright, I disconnected this low side of the volume control lead, which goes back through the filaments to ground, and the low resistance is still there on the input of the volume control. Now that goes back through this 2.2 meg resistor, that connects there, so we know that is not at fault. And just to be sure, we'll just go back and measure at the other end of that resistor, and we have an open circuit. This capacitor here, this mica capacitor, connects from that point on the volume control to ground. It's highly unlikely that's shorted, but I suppose it could be. And then we have the IF transformer that goes back over there to ground. Not to ground, but yeah, here's the other end of that winding. That's where the RF comes out. Alright, I lifted the mica capacitor, even though I didn't think that was the trouble, and it wasn't. Then I lifted the volume control. The only thing connected to the volume control is this coupling cap off of the center terminal. And when I touch my meter probe to the input pin, I'm still reading 58 ohms to ground, so there's some kind of leakage inside of this volume control that's providing a leakage path to the chassis here. And on that note, It's time for me to go up and put my chicken pot pie in the oven. And after supper, we will see what's going on here. Well, that was irritating. Went up and put my chicken pot pie in the oven, which is electric, by the way. And within 5 minutes, the power goes out. And it was just barely raining outside. It wasn't hardly even doing anything. But, you know, I've lived in this same neighborhood for most of my life, and growing up, I don't remember the power going out nearly as often as it seems to be going out here lately. In fact, it had to really be something bad, like an ice storm, which is something we rarely get in Mississippi, or possibly a tornado or something like that, or some drunk hitting a power pole and knocking it down. But just within the past month, it's gone out several times, and a few times it wasn't even bad weather. It was pretty outside, so I wish they'd get their act together. Fortunately, tonight it was only out for about 30 minutes, so maybe supper can be salvaged. I really think what's going on is they're just not keeping up their systems as well as they did 30 years ago, and that's the reason the power is going out at the drop of a hat. Alright, enough about the power company. I'm going to try to salvage this control now. Evidently it's got some kind of contamination or tin whiskers or something in it that's providing a path from this terminal to the chassis. And I'm going to try to flush it out real good with the cleaner and see if that'll make the leakage go away. Hopefully it will. If it don't, then we may have to pull the control out and take it apart and see what's up with it. Alright, I hosed the crap out of it with cleaner and kept rotating it back and forth. And I'm on the 2 meg scale on my meter, and it looks like the leakage has dissolved itself. Now, how long that'll last, I don't know. Hopefully indefinitely. So let's connect everything back up and see if the radio will play normally. Well, I hosed it down, cleared the leakage, soldered everything back up, and now it's back again. I'm about ready just to put this thing back together and put it on eBay as a non-functioning display piece and be done with it. Well, it's weird. I can spray the pot, clear the short, plug the radio in, and as soon as voltage hits it, we fail to operate, and then the short comes back. So I guess I am going to have to take this out and try to repair it, take it apart and clean it or do something. Alright, what you just heard was the audio that would normally be going into the volume control. I lifted that connection, and we definitely have audio going there. Just we have a volume control that for some reason has some leakage to the chassis. Alright, I have the volume control isolated from the chassis. Bring it in contact with the chassis, it shorts out again. Well, I got the pot out and the leakage appears to have cleared itself. And this is why it's getting so I'm not that interested in fixing these things. I get them fixed and all I hear is something about Colin Kaepernick. I couldn't care less about Colin Kaepernick or whatever his name is. I want to hear nice, good programming on AM, but instead I'm bombarded with that kind of garbage. Alright, I put the volume control back in and it's now working. I don't know what happened. I don't know whether there was some piece of conductive debris between the volume control and the chassis, and whenever I removed the control it dislodged it or what, but it's now working. Not that great, but it's working. So I guess now I'll put the dial scale back on and align this thing and be done with it. Alright, I'm tuned to 870 WWL and I'm just going to align this by ear.
It's the only plan with the AARP name. So if you're turning 65 or have questions about the mysteries of Medicare, make that one call to United Healthcare at 1-844-3-GET-UHC. That's 1-844-3-GET-UHC. Or go to GetUHCMedicareToday.com.
Paid active insurance benefits and availability may vary by plan and location.
Where's the other one? Back here where I can't get to it?
Intellectual property. AARP and its affiliates are not insured. AARP does not employ or endorse agents, producers, or brokers.
Now our oscillator is off. So I'll adjust this to get it back on.
CBS Sports Radio toll-free line.
This is still pretty lackluster. Alright, this is about as good as it gets.
Activity. So if you're a couch potato, here's what happens. Muscle mass diminishes, the metabolism can change drastically.
And that's probably about all this set is capable of doing.
Regulate temperature and weaken bones.
This speaker's not in great shape. It's got a dragging voice coil, but I'm not too concerned about it.
If you simply exercise can make a huge difference.
It's not like this is one I'm going to be using all the time, and if you listen to it at normal volume, it's not as big of a problem. Yeah, that's not moving very freely, and that's another reason why it's probably not quite as loud as it could be. I have some 3.2 ohm 4-inch speakers coming, and the mounting of the speaker to the chassis won't be a problem. That's conventional, but where the problem comes in is where they have the audio output transformer mounted to the speaker, and the newer speakers don't have provisions for mounting an audio output transformer, so may have to get creative with that. But for right now, it's going back in the cabinet, and I'm not going to worry about it. Alright, I have it plugged into the old school Silvertone power shifter. And apparently one of the knob retainers fell out. I don't know where it went. I didn't know it was gone until I got ready to put the knob back on.
Well, Professor.
Yeah, I'm just starting to get fed up with radio. I mean, if I could fix these things up and sit back and relax and listen to some good music, that would be one thing. But no, I'm stuck with Mike Gallagher or Dave Ramsey or Fox Sports on one station, or some urban gospel stuff on another station, or more sports on another station, or the preacher on another station that wants you to send him a donation for telling you that the end of time is near, which it may or may not be. I don't know. That's not my place to judge that. Okay, I've had this radio on for about an hour now, and it seems to have improved. And when I say improved, I'm talking about the speaker.
People who are out of work through no fault of their own, and the Democrats, everything's a non-starter to them. They won't negotiate in good faith. They went home. They're coming back.
It actually gets louder now, and it sounds better. So I think probably what happened, just me running the radio and the speaker vibrating, whatever crud was in the gap there worked loose, and that's a good thing because I really don't want to have to try to replace the speaker.
To mail in their votes so that Grandma can vote, any way you want.
I pulled the chassis back out to go over it once more because this is a 5-tube set with 2 IF amplifier tubes. and I actually have a 4-tube set. It seems to be a little bit perkier than this one is, so went through and tested all the tubes. The oscillator and mixer tube was a tad weak. I replaced it with one that tested stronger, although I may have to extend this grid cap lead just a tad bit, because the tube that was in here was one of the taller variety, and this is one of the short ones, so we'll just see how this tube does first. I did test the speaker, and I'm getting no more dragging when I give it the cone test, the push test on the cone, so whatever was in there worked its way out, thank goodness, so I don't have to worry about replacing this speaker. Alright, let's get the antenna hooked up, and we're going to connect the signal generator and align it properly this time and see if it does any better. And then I got to fix up the battery connections, and then we're going to build a battery pack so this thing can truly be a portable radio. Alright, here we are connected to the signal generator and set to 455. Turn that output down a little more, and we'll just peak each trimmer for maximum. Yeah, that one was a little off, so that just goes to show that doing it by ear from a radio station is always not the best thing. Okay, they want us to set the signal generator and the radio to 1400 and then feed the signal from the generator to the antenna input of the radio via a 100 picofarad capacitor, so we can adjust the oscillator, and the correct adjustment of that will help ensure that the dial is accurate. Well, we can't do it on 1400 because we got 1390, so we're going to do it on 1300. Alright, let's see here. Alright, that was pretty close. Now let me try some other frequencies and see if it's right. Let's go to about 800. Alright, we got something going on again.
Free in-home water test with the local college verdict.
I'll set the radio down and try it cuts out again.
Come to AutoZone. Dealing with battery. We've got you.
So we got to look into that. Okay, I found the trouble. Dummy me forgot to tighten the volume control retainer nut down when I put all this back together, and since I'm using the volume control housing for a ground for that capacitor, the volume control wasn't making good contact with the chassis, so I tightened it down and all is well now. So I think now we can put this back in the cabinet and fix these plugs where they'll look a little bit neater, and then except for making a battery pack for this, we'll be done. Okay, the A connection is fine, so I'm going to leave it alone, and I've already repaired the leads on the B connections, and I put a little piece of heat shrink tubing over them just as a little added safety measure. And I can tell you how those got like that. People grabbing the cable by the wire itself and yanking on it instead of grabbing it by the plug. And I know it's sometimes hard to do, and sometimes those plugs are very tight fitting in a battery or a battery eliminator, but you really don't need to grab the wire and yank from the wires. You need to grab the plug and yank it from the plug. Alright, we're back together. I got to find a insert to go in this other knob where it'll stay on the shaft. We have the outdoor antenna connected. That helps it a little bit. Turn the light off, get rid of every interference source that I can get.
You know?
I think that's the country station on the Gulf Coast. There's another weak one.
Alright, who's playing right now?
Getting a little bit of DX at the top end of the dial, but that's not too bad.
The Jackets today 2-1 to Tampa Bay's up 3-1 on that. So they're in the game for?
That's not too bad considering it's, what time is it? Almost 5 o'clock. Alright, so next we need to construct a battery pack so we can use this radio as a portable as it was intended in the first place and not have it strapped to an AC power supply. Alright, for our 90 volts, we're going to put 10 9-volt batteries in series, and for that purpose, the cheap ones will do. These are some I ordered off of eBay. There's no need in paying the $2 or3 a piece for the Walmart alkaline batteries. Get the cheap ones. Alright, here's our 10 9-volt batteries clipped in series, and that gives us 99.7 volts. That's close enough to 100 for government work. All we need is 9 in. The radio will probably play as low as 75 or 80. So, and yes, I've already touched my fingers across the battery terminals, and no, I didn't get shocked, but that's not something you would want to short out, or you wouldn't want to put your tongue across the whole string of it. And I'm going to go ahead and tell you, this is not going to be very neat and professional looking. This is just something that I'm going to cobble together just to have a portable tube radio that will work the way it was intended to work, and no more than I'm going to use it. It's not like I'm going to have to change the batteries in a week. And here's a couple of D's that we're going to put in parallel for the filament supply. That'll still give us 1.5 volts, but the current capacity will be greater, and for something that's drawing, I believe, around, according to the schematic, around 300 milliamps, that'll be needed. And I'll tell you, these filament batteries will most likely die before this string of 9 volts will. Yeah, 300 milliamps on the A line, 10 milliamps on the B line, so you understand why I say that you don't need the expensive 9-volt batteries for the B supply. For the A supply, it would be best if you used alkaline batteries, but carbon zinc batteries will still work. You'll just have to change them more often. And you know, this is not a transistor radio. This is not something you want to use as your primary portable receiver and have the batteries last a year or two. You know, this is something you want to use every now and then and use it in brief intervals. I knew a guy that grew up during World War II on a farm, and he said batteries for the radio were hard to get. He said what they have was one of the Silvertone table model sets and a wooden cabinet, and it used one of the big 90 volt and 1.5 volt packs. And he said the only time we were allowed to turn the radio on was for a few minutes in the afternoon to get the war news. He said my daddy was a stern man and he didn't take no bull crap, and we knew he meant business when he told us we were not to turn that radio on except to get the war news. He said it would not have been pretty had he come in and caught us with the radio on listening to music on it, because he knew that when that battery went dead that he might have a hard time finding another one. Well, this is about par for the course. Some time back I ordered some 9-volt snaps and some D-cell holders just for the purpose of making these battery packs. Well, as what often happens, I hit it really well, in fact so well that I can't even find it. So just because I got pissed off, I ended up just soldering the wires directly to the batteries themselves. And then I ended up having to cut the battery plug off of the radio so I could make the connections to the radio. My first thought was to try to leave it as original as possible, but then my second thought was, the types of batteries this set uses, they probably hadn't made in 60 years. And I'm looking for a modern way to make this work. So for right now, it's going to get jake-legged together. And probably whenever I come up with the right stuff to properly make a battery box, we'll just put some modern terminals on these leads and make it to where it can be easily connected to a battery box. And the original plugs, I'll put them in a little Ziploc bag and put them in the back of the radio in case somebody ever wants to convert it back to like it was original. But I'm all for making it usable. Nobody's going to see it with the back on it anyway. But yeah, this is about as jake-legged as it gets.
These steps aggressively. Cintas. Visit Cintas.com. Cintas, ready for the workday. First American Bank celebrates the American.
The baby that she would change her mind and want to have another baby.
The confidence and the change of career just made you go.
Federal prosecutors say Maugay China classified FBI documents.
I don't know what all the squealing and birdies are.
As well, some of the safeguards that are in place.
Alright, let's disconnect the outdoor antenna and take it up on the table up here and see what happens.
They don't have great.
I want to know him, that I may know him. And the...
And gets married. Life is good. $80,000 paid off in 10 to 130. Count it down. Let's hear a debt-free scream. 3.
I can't deal with him anymore. I've heard enough of him for one day. It's real easy to tell everybody else what you need to be doing to be debt-free when you're a billionaire or pretty close to it. You know, we're not on the outside antenna now, and up here it appears all the birdies and oscillations have gone away, so must have been picking up some interference from somewhere.
55, I'm 37. We have 2 boys, 12.
Alright, I jake-legged the volume knob with a piece of cardboard, so it'll stay on now until I can come up with a proper metal piece, the knob retainer.
Yes. Louis. We're endorsed local providers. I'm not going to endorse you.
Sudden, I hear rain. Not the change for you.
Yeah, it does pretty good. You know, it's after dark now, and I'm out here with a flashlight. Got WDIA coming in faintly. Got some Jim Croce coming in very faintly, with the volume turned way up.
George Flynn on
Sandy 103, I believe I picked him up before.
Number to create equal action.
That is WABF out of Mobile.
Fun.
Look at that. SEC, ACC, and Big 12 all.
I think that's WSM coming in faintly, but yeah, I would have figured this radio would have been a little more sensitive than what it is, but you know, it is what it is. It's working as about as good as it was probably ever capable of working. And one day I'll get around to fixing up a proper battery for this. I wish somebody would make reproduction battery boxes for these things that you could put modern batteries in, but you know, that probably wouldn't be cost effective for them, because most people, probably including myself, probably wouldn't want to pay the price. But it's back playing again, and that's that. There comes WSM.
It's on various sources on the internet and lasts a good half hour, where Merle sits down with Dan Rather and talks all about and opens up about fearing dying alone and talking about music. And they talked about this song, and I loved it because when I interviewed Merle Haggard, boy, that was back in 99, I believe, is when I had the opportunity to talk with him. And we talked about this song. This was a staple of my live performances for years and years. And I asked him what one of his best songs was in his estimation. He told Dan Rather the same thing, that it ranks right up there among his finest work. And Joe Nichols recently cut this song and does a stellar rendition of this Merle Haggard classic. Turn this up and enjoy. This is Sing Me Back Home tonight on The Legend, 6:50 a.m. WSM.